Chemical waste is a byproduct of many industries and can pose a serious threat to human health and the environment if not properly treated and disposed of. Chemical waste includes hazardous chemicals, such as heavy metals, organic solvents, and toxic gases, which can cause a range of health problems, including cancer, respiratory problems, and neurological disorders. In this article, we will explore some of the most common technologies used for the treatment of chemical waste. Incineration. Incineration is a common method of treating chemical waste that involves burning the waste at high temperatures, typically between 700 and 1200 degrees C. The process converts the waste into ash, gases, and heat. Incineration is effective at destroying organic compounds, including hazardous chemicals and pathogens, and reducing the volume of waste. However, incineration can also release toxic gases, such as dioxins and furans, and requires a significant amount of energy to maintain high temperatures. Chemical oxidation. Chemical oxidation is a method of treating chemical waste that involves using chemicals, such as hydrogen peroxide, ozone, or potassium permanganate, to oxidize the waste. The process breaks down the chemical compounds into less toxic or non-toxic compounds. Chemical oxidation can be effective for treating organic compounds, such as polychlorinated biphenyls, PCBs, and reducing the volume of waste. However, the process can also produce hazardous byproducts and requires careful handling of the chemicals used. Bioremediation. Bioremediation is a method of treating chemical waste that involves using microorganisms, such as bacteria or fungi, to break down the waste. The microorganisms use the chemical compounds in the waste as a food source and convert them into less toxic or non-toxic compounds. Bioremediation can be effective for treating organic compounds, such as petroleum hydrocarbons, and is often more environmentally friendly than other methods of chemical waste treatment. However, the process can be slow and requires careful monitoring to ensure that the microorganisms are working effectively. Physical separation. Physical separation is a method of treating chemical waste that involves separating the waste into different components based on their physical properties. The process can include techniques such as filtration, sedimentation, and centrifugation. Physical separation can be effective for removing solid or liquid waste, such as heavy metals or organic solvents, from other components of the waste. However, the process may not be effective for treating all types of chemical waste and may require additional treatment methods. Stabilization and solidification. Stabilization and solidification is a method of treating chemical waste that involves adding materials, such as cement or lime, to the waste to bind the hazardous chemicals and reduce their mobility. The process can also involve encapsulating the waste in a solid matrix to prevent the release of hazardous chemicals. Stabilization and solidification can be effective for treating hazardous chemicals, such as heavy metals, and reducing the volume of waste. However, the process may not be effective for treating all types of chemical waste and can require careful handling of the materials used. In conclusion, the treatment of chemical waste is an important aspect of environmental protection and public health. The technologies used for treating chemical waste vary depending on the type of waste and the desired outcome.